the ways that we write the derivative. What's the derivative again? What does it mean? The slope of the tangent line, okay? In your head, that's what you got to think. So, slope of the tangent line. We aren't most of the time going to write out the whole word derivative, okay? So, one of the ways you might see it is this notation dy dx, okay? And all this stands for is, if I asked you, like in Algebra 1, how would you find the slope, what would you tell me? Rise over run, or the change in the y's over the change in the x's. dy, for all you science people, is delta y. What's delta mean in chemistry? Change in y over the change in x. So you're not going to see it that way, but delta y is the change in the y over the change in x. And that hopefully makes sense because that's all slope is. It's rise over run. Okay, you're going to also see this little apostrophe here. So y prime, if it's a function, or function notation, f prime of x. And oh no, the delta x thing, the triangle thing. Yes, we will. Okay, we won't see this one. This is probably the least likely way you're going to see it. Okay, these three definitely more popular, but let's talk about this. Because what's going on here is if you had a function, how would you find the y values? Wouldn't you plug the x value in for the function? So all we're doing here is we're finding a point that's super close to x. Because delta x is like just a little bit, it's almost 0. It's a little bit away from x. And we're just finding the y values, and then we're subtracting the x values. That's essentially what's going on. Here's what the two versions, I use this one the most, probably. Okay, and all this is the slope formula. Again, it's the same idea. What you're going to do is you're going to have, if we want to find slope, the problem is if I wanted to find it at one point, I can't do that because on the bottom I need to have a subtraction that's not 0. So we pretend to find a point that's super close. It's so close that it's approaching 0 away. Like think of a number really, 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 really small, like 0.00000001. If I told you to round that, wouldn't you round it to 0? Okay, so this plus h part means it's just really close to x. And what it allows us to do is it allows us to find the slope then because I have a very small point or differential there. This is the same idea, except this is at a specific point. Okay, so I'm doing a slope at a point that is, again, really close to x. I'll use this one sometimes. The big deal today is, do you remember how last chapter, how we removed zeros on the bottom of limits? Because we're going to be doing this again, right? So what we're going to run into is we're going to run into that thing where we put a 0 on the bottom and it's undefined. What are some ways that we, on our last test, removed some limits? We did some factoring. We did some, what was that thing? Rationalizing. We did a little bit with fractions, putting them together. So today what you're going to see is you're going to see some limit stuff again, which is actually going to be okay because you know how to do that. So let's begin. Okay, first of all, I'm going to use the definition of the derivative just to demonstrate it. But who already knows what the answer to question 1 is without doing the work? 4, because we're trying, if it's a line, think of the line, 4x, aren't all the tangent lines going to be the same as that line? And the slope of that line is 4. Okay, but let's use it because we know what the answer is going to be to demonstrate the definition of the derivative. This might look familiar to you after we do it because you might remember it from last year. We did it at the end. I'm going to use the definition that looks like this. The limit as h goes to 0 of f of x plus h minus f of x over h. Okay. So what I like to do for things is, this one's going to definitely be a little bit more involved. But what I like to do for these kinds of problems is write out some, because I think people get lost, there's a lot going on. I write each of these pieces out so I know exactly what they are. Okay, so, and then I plug them into the formula. What's f of x plus h? If I rewrote that as an f of x plus h. So function notation means that if f of x is 4x, how would I write f of x plus h? That's what I'm asking.
4x plus h.
4 parentheses x plus h. Okay. And then f of x is just 4x. Agreed? Now what we're going to do is we're going to rewrite that equation with the things that we know. We pick a different color because we're doing something different. All right. So the limit as h goes to 0, and for f of x plus h, I'm going to write in this spot right here 4 parentheses x plus h, and then I have to write minus f of x, so I'm going to write minus 4x, and then on the bottom is just an h. Would we all agree if we tried to evaluate that limit, we could not do it? Because what's on the bottom? 0, because I'd be putting 0. All right, let's see if we can do some expanding and get rid of that h on the bottom. So we do that. I'm going to distribute 4x plus 4h minus 4x all over h. What do you notice happens? Give me one thing.
4x cancels out.
Look, one of the things is the 4x's cancel out. Good. And then now I have 4h over h. So don't those cancel? The h's? So now I can't even plug in the 0 because it's still a discontinuity, but it's been canceled out. So do we see then that that limit would just be 4? I know you told me that it was 4. Here's what I'm going to tell you from now on. Lines you don't have to do, just, okay? I was just using it as a demonstration, because why would you do that all that work if you knew the slope of the line is going to be the slope of the tangent? So, all right. So let's do something more complex. So example 2, find the equation of the tangent line. Whoa, okay. This is our first time experiencing this. This we do so much this semester. So before we start, let's figure out what are the things you need to find an equation for a line. So one of them is we would need the slope of the tangent. And that's what we've been doing, right? Like up here, this is the slope of the tangent. Okay, so we would need the slope of the tangent. So we're going to find that in a minute using the derivative. And then everything, guys, leave in point slope form. Because on the AP exam, they allow you to do that. Don't make your life harder than it is, okay? Calculus is hard enough. We're going to leave everything in point slope form. So the other thing we're going to need is a point. Now, before we begin, which of those two things are you given? You're already given the point. So that's nice. Our equation is going to be like y minus y1 equals mx minus x1. And we're going to plug in that point, negative 3, 4. Now, our job is we have to figure out what the slope is. Okay, this one is a kind of a lot of algebra. Are we ready? It's Monday morning. Whew. All right, so I'm going to go ahead and rewrite my formula again. So we have f of x plus h minus f of x over h. What is this again? What's this called? What? Oh my gosh, hypotenuse. No.
It stands for something?
Yeah, what is this?
Oh, the
It's,
derivative.
you could say the derivative, the slope of the tangent line. This is the slope of the tangent line, okay? That's what this definition stands for. Start being able to see when you see this, oh, that's this, because what you're gonna learn in a few days is you're gonna learn a bunch of shortcuts for things. Like I already know what this is.
Can you
What?
tell? Can you tell?
Well, I will tell you, you want me to tell you what the answer is?
Yeah.
Um, it's -12.
Well, I can't fact check you.
Okay, so, but what I'm telling you is you will know this too, but this is a very important concept, so for a few days, we are not doing shortcuts, because we gotta know what this stands for. All right,
Does H stand for something, or is it just a letter?
it's a letter we make up because we need to pick something to find the slope. So it's the letter we picked to make the point really close. All right, we're not expanding yet. F of x plus h. We're going to rewrite this. And so instead of x squared, what are we going to write? X plus h squared plus 2x, so plus 2 times x plus h plus 1. Are you guys all seeing that? So I'm just taking this function and rewriting it with an x plus h. Okay. Now, the same thing's going to happen in a minute, and I'm going to need some things to cancel, so I'm going to expand this. X plus h squared is x plus h times x plus h. What's this distribute to be? Two x plus 2h plus 1. Okay, I'm going to give you a minute. Would you expand this and then add any like terms? I didn't get any like terms. Did you get any like terms? No. Okay, so I got x squared and then I got xh plus xh. So that's why I wrote 2xh plus h squared. This was 2x plus 2h plus 1. Okay, the reason why, this is why I write this stuff on the side, because all of this is f of x plus h. What was f of x again? X squared plus 2x plus 1. Okay, let's begin. We're going to do our work over here. All right, so I'll try to go slow. The limit as h goes to 0. For f of x plus h, I'm going to put that whole thing down. So it's x squared plus 2xh plus h squared, I want to leave enough room, plus 2x plus 2h plus 1. Okay, now I'm going to do my subtraction symbol, minus, for f of x, I'm going to do this whole thing, but make sure you put it in a parentheses. X squared plus 2x plus 1. Okay, and then all on the bottom over little old h. So here's what I'm going to have you do with your groups in your tables. If this negative applies to everything in here, can you guys cancel some things out for me? Just talk it through with your table mates. On the top, if this negative applies to everything in that parentheses, let's talk about what things you can cancel. So I heard an x squared. Are we all in agreement about that? What else? Okay, 2x minus 2x and the 1. Okay, well that was kind of cool. Now what do we have left? If you're going to notice, all the terms that are left, do you see them? What do you notice they all have in them? An h. And so what I'm going to do now is I'm going to rewrite this, and I'm going to rewrite them with division out of the h. Okay, so what's 2xh divided by h? Yeah, so we have the limit as h goes to 0 of 2x. And what's h squared divided by h? Plus h. And what about 2h divided by h? Just plus 2, right? Okay. So the limit as this goes to 0 is 2x plus 2, right? Are we all okay with this? Okay. Oh, I was wrong, Whitney, about my shortcut. What's that? It's because I tried to do it in my head and I have to write it down. But okay, now, what were we doing again? Oh my gosh, it's been like stinking 10 minutes since we started this problem. Let's go back to the exam. Find the equation of the tangent line. Oh, we were finding the slope, weren't we? Okay, so here's what this is. The derivative, the slope of the tangent, is a formula to find the slope at all of the different points. Okay, so this 2x plus 2, if you're going along that x squared parabola, if you plugged in the x value, it would generate what the slope is at that point. The reason why we didn't have an x in this is because the x dropped out because it's always consistently 4. The reason why you see an x in this is because if I have a parabola, I don't know exactly what it looks like, but isn't the tangent line going to have a different slope here as opposed to here, as opposed to here? Okay, so what this formula is going to give us, this derivative, is it's going to generate the slope for us. So we need to know at which point, but we have the point. What's the point that we're asked? At -3. So we're going to do 2 times -3 plus 2, and I plug in that point from up here, and -6 plus 2 is -4. This is our slope. This is our point. And so my equation for the tangent line would be y minus the y coordinate, which is 4, equals -4 times x minus the x coordinate, which we would rewrite as x plus 3. We can leave it just like that. Okay. I know, kind of, it's a very long process, isn't it? Okay, if you're wondering what we just found, are you ready for the aha moment? I'm going to graph this and I'm going to show you what you just found. I'm going to put in x squared plus 2x plus 1. Okay. That's the parabola. I'm going to go ahead and get to the point -3. So do you see it right there? Yeah? I just found the line that's the tangent to that. So if I were to put it in another y equals, I'm going to just put -4 x plus 3, and I'm going to just move that 4 to the other side. I just found the line that's tangential. Okay, so if I went back again, let's see, I zoomed in. You could see it a little, this is the curve. There's the tangent line of that one. You might not think that's cool, but I do. That's what we were finding, slope of the tangent. Whereas before we were just estimating it, now we have a way to find it exactly. What's going on? I want to stop my recording.